Stop paying for servers. We fit an 80B LLM onto your MacBook with only 4 GB of RAM. The promise of AI is incredible power. But the reality for most developers trying to run models like GPT-4 or Llama.cpp is a painful bottleneck, cloud costs, API rate limits, and crippling latency. The barrier to entry for truly powerful AI used to be infinite server farms. But by understanding the optimization stack, we tear down that barrier entirely. This is where the magic begins with quantization. Traditional models store weights in 32-bit floating point, are massive, but redundant. Quantization aggressively compresses those weights down to 4 or even 3 bits. Think of it like scaling a massive orchestra down to a small chamber group, but crucially, without losing the musical integrity. You drastically reduce memory footprint while preserving functional accuracy. But compression isn't enough. We need a standardized container format that understands these compressed weights and maps them efficiently to limited memory. Enter GGUF. GGUF is the universal language for these models. It's not just a file, it's an architecture that allows the inference engine to memory map the weights directly from disk into RAM as needed, bypassing expensive CPU overhead. This memory mapping ability is the true game changer. It means your 4GB MacBook Pro isn't trying to hold the entire model in volatile RAM simultaneously, it's intelligently accessing it on demand. And finally, we need the driver, the inference engine. Frameworks like Llama.cpp are purpose-built to handle these GGUF files and execute the matrix multiplications using optimized CPU-GPU instructions. It's the combination of these three pillars, quantization for size, GGUF for structure, and Llama.cpp for execution, that transforms a prohibitive cloud expense into a zero marginal cost local operation. So, if you're ready to go from paying per token to absolute control, you need to start here. Find a reputable GGUF checkpoint and match your hardware's limits. This shift isn't just about saving money, it's about achieving AI sovereignty. You control the data, you control the cost, and you control the deployment.